Well, hello friends. Today we are going to keep working on the profile viewer, and what we're going to do today is we're going to make like a little track, I guess you call it, something where we can see the run that we recorded on a time scale, so that you can see like first second, second second, third second, and so on, and all of the samples gathered, sort of graphed out. And then the idea is that you will be able to select like a part of the graph if you're only interested in looking at like a certain part of it, like a certain time slice or whatever. So I guess timeline is the right word. So actually now I wanted to make a profile of something. So we're gonna make a recording of something. I think we'll use, what are we gonna use? What's interesting? We can use paintbrush again, maybe. Or yeah, that's okay. We'll use paintbrush. So, oops. Let's get the PID is 16. So 16 on. And I'm just gonna prepare by choosing the pen here, and we'll just draw a little bit. And then we'll do some bucket filling. And then we'll also do a little bit of spray. So we'll get a few different types of things. And then we will save the profile. I'll just call it PB. Okay, and then let's have a look at it. So we can see here, by the way, here's a new feature in the profile viewer. All the kernel stack frames are going to be red, little red icons, so you can tell them apart. So I guess if we go into the deepest here, I didn't actually end up calling the kernel. Well, I guess I thought it would. Here we can see calling the kernel, doing some munmap. I guess this is not a very kernel heavy workload, although we do have a little bit of malloc and free, which ends up calling the kernel, and you can see that their kernel functions are in red. So just a nice little visual cue to help you keep track of what you're looking at. Also, I realize now that this thing here is disappearing when I scroll down. Oh, it's so stupid. It's not supposed to do that. I totally did not realize the headers, they follow with page. Can I still click on these? I can still resize them. Yeah, so they're still there. It's just that everything gets all confused. Anyway, we should just fix the painting. But that's not what we're gonna do now. We're gonna make a track. So above this tree view here, I wanna put a track that spans from the left side of the window to the right side of the window, where we just plot out the profile that we have. And we'll start by just making something for that. So I think we saved this, right? So let's just make sure that we have it. Mount, disk image, mount, cp mount, home and on, and we'll save this in base home and on. We have a profile there already. We'll save over that one. Okay. And pbrush.prof. Okay, now let's go and create a class for this new thing that we're going to make. So in profile viewer, we need something like a timeline widget, maybe. Is that a good name for it? Timeline, profile, timeline. Profile, timeline widget, profile widget, profile widget, time, track, profile, profile, timeline, widget. It's better to be too verbose and too precise than not precise enough. This will know what it is. Okay, so let's create this thing. It's not an about dialog, geez. It's going to be a G-frame, I think. So profile timeline widget, G-frame. Okay, and then I guess we'll say C object profile timeline widget. Something like that. Class profile. All right. And for this thing, we are going to want to have definitely a virtual destructor out of line, and we are going to want paint event. How did you know? You just knew. Can be private. Then I think we're going to need some mouse event. Will you know if I start typing? No, you don't. Okay. Mouse down event. Mouse event. Sometimes he just knows. Other times he doesn't just know. So we'll do those. And paint event can't be redeclarable. I'm sorry. Okay, so I think maybe these are what we'll start out with. And let's make sure that we create one. So this will be in profile viewer main. So we'll make a little main widget here. G widget construct Windows set main widget and I guess we can call this something like main widget actually. Main widget set layout. Make Gbox layout. Orientation vertical. Seems like we need Gbox layout. It's nice to be in this way of programming again, because like the video I posted yesterday of like profiling and then optimizing based on that, it's fun to do that, but it's so different from just you know, hacking stuff up. It's like a different mindset completely. So let's see. We have layout, and then we will make ourselves a timeline widget. Profile timeline widget. Construct main widget. Maybe that's all we need to do actually, and give it the profile. I am so excited about this profiling stuff, by the way. It's like funnest stuff ever. Let's see, can we build it? Yes, we can. Okay, so profile timeline widget. I mean, everything in this operating system is the funnest thing ever. It's just, it's just lovely that there's always something new coming up that's also the funnest thing ever. And unlike all of my projects, like hobby projects or anything I've ever had in the past, it's not like, this time it's not like I start something new that's really fun, but it just fits together with the old stuff that's also really fun, and it doesn't take away from it. They just add to each other. It's amazing. I hope everyone can have a project that they feel this way about, because that would be super sweet. Okay, so now we have our basic class skeleton. Let's do some frame setup, frame shadow. We'll just do a regular sunken container shape, container standard. And maybe we'll also do set background color white. Fill the background true. All right. And we're going to do something else super fun too, like set preferred size. Horizontal, nothing. Vertical, how about 100? How about that? Maybe that's a bit on the tall side. We'll say 80. And fill and size policy fixed for vertical. And then we need all of those event handlers. Paint event. And mouse down. G mouse event. Oh, wait, that didn't look right. And mouse up. And mouse move in between. I like to put them in this order always, or when I remember, like down, move, up, because that's the order that they happen. It gives me some weird little everyday satisfaction there to see them in order like that. You know what I mean? Maybe you know what I mean. Probably you do. So, what am I doing wrong here? I must initialize the M profile reference, of course. So let's make sure that we have that, and then we can probably just build this and see that it shows up. It looks like a sunken container frame and that it's 80 pixels tall. And that did not work. Why did that not work? Wait, where did we even die? Set main widget is not working out. Why is that? Profiler, viewer, main. I'm calling set main widget twice, of course, which I should not be doing. Because you can only have one main widget in a window. Sometimes I think about Qt and the way that they do like implicit window main widget, because like the outermost, any widget in Qt that doesn't have a parent becomes a window, basically. And you could imagine doing that here, but I kind of like having an explicit window instead of having widgets implicitly become windows. It's nice to have to spell everything out, because then you don't put like window-specific things in the widget class, which I always felt was very messy in Qt. Anyways, just a thought. So here we are. It doesn't look exactly like I was expecting, but nevertheless. Oh, I guess it's because we're not painting it. We need to actually paint something here. What is the thing? Gframe, paint event, event. I think that's what we need to do. Okay, now we have the right look, although we have the wrong color here, which is the main widget bleeding through. So it's this guy right here. We'll just set him to main widget set fill with background color true. Get some of that warm gray in between those child widgets so that things look right. So let's fill something interesting into that thingy. It's a profile timeline widget. What are we going to paint here? Well, we want to paint the whole profile that we've opened. So we have it in profile, but we want to iterate it from left to right. And I guess first thing is we need to find out how many, how long is it? Like how far apart are the things? So we can look at it here, actually. Just look at the JSON data. Oh shit, that's not very friendly. No, is that not how you do this? This is how you do it. All right, so here's each, I mean the whole thing, actually. So this is what we get for each sample. We have a PID, thread ID and a timestamp. And this timestamp is number of milliseconds since boot of the operating system. So we can actually use this, and we just take the first timestamp and the last timestamp, and that we can subtract those, and we'll figure out how long is the profile, right? So let's start with that. We'll do like maybe use 64, but length in MS, or well, we don't have to be too ambitious here. So turn and length in MS, or you know what? Let's use 64. I'm feeling it right now. So length in MS. Now we gotta parse that out. So where's the function that actually does this? Profile node. Oh, wait, hold on. This is the wrong place. It's not the profile node. A profile node is always 1 millisecond. It's a profile that needs the length in MS. I was putting this in the wrong place. Okay, so where we parse this guy in load from file. So we'll do something like this. Samples dot at 0. I guess we'll say if samples is empty, return null footer, because we don't want no empty profile. Can't open that. So samples at 0 dot as object get timestamp as youth 64 first timestamp and last timestamp is going to be sample size -1, and that means that I guess we'll say the first timestamp and the last timestamp. We'll just do it this way. We'll say both of them. Then we don't have to compute the difference here, actually. Wait, what's going on here? Samples is copy constructed. Well, why don't we do it that way then? First timestamp. Okay. 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 Guess we'll also do, well, we'll provide these timestamps for the outside world. Okay. Now, we also want to have a way to get the timestamp of a profile node. So we'll store that in each one. M timestamp. This is going to be important because when you're profiling, it's perfectly possible that you go like multiple seconds with no samples, right? But we don't want those to show up all right next to each other in the view, in the timeline view. We want the time where nothing is happening. We want that to be accurately visually represented as well. So we gotta keep track of everyone's timestamp, basically. Timestamp. And where do we create one of these guys? Well, it's here. Timestamp. This code feels a little bit on the redundant side. feel like there's some duplication here that I could get rid of, but it's not something that we have to think about at this very moment. So timestamp. And finally, we are going to extract the timestamp. Aha. Okay. What happens when you do as U64? Is U64? Two. Maybe we should use 2 U64 instead. Now that I think about it, 2 number U64. That's what we want, because otherwise, if the number is small enough to fit in a U32, then the JSON code will get cranky at us because we're trying to tell it, hey, you have a U64, which he doesn't. He has a U32. So we'll just ask him to give us a U64, knowing that it might be something other than that internally. So first timestamp. Last timestamp. All right. And okay, did I get everything? Hopefully I did. So let's see what we can draw here. I guess we'll just need to iterate the profile. And what's the best way to do that? We have the vector of roots right here. But what we want is really more like the, we don't want to iterate the profile nodes. In fact, the profile nodes are not super interesting to us. I mean, it's okay to keep the timestamp for them, I think, but what we really want is iterating the JSON array. So we can let you do that. JSON, we can do, we have a for each thingy, so for each sample. So we'll make a little templated callback thingy. We'll say for each sample, callback, and here what we'll do is JSON for each value, then here we will call back the value. Just yeah, that's what he does. Okay. That kind of works. Maybe that's simple enough, actually. For each sample. Then what you'll get out is a JSON object. So we can actually do that just to be nice to you. So you will get a JSON object out, which you can then query. Although, yeah, maybe that's good enough for now. Okay, so for each sample, auto, we'll do const JSON object. Something like this, sample. What are we going to do? So the time offset is the timestamp of the sample minus the first timestamp. So we'll start by computing that. Time, or the t, I guess, if we have the t-axis. So T is sample get timestamp. We should probably pre-convert all those things in some kind of pass, but right now we don't have that, so we'll just do it this way. Get yeah, that's okay. And what is the thing that we want to do here? I guess we want to figure out. Well, let's just print these out and see what we can see so far. So we'll just print these out. T is at maybe just print that. Okay, so these are our timestamps of our samples. Sounds about right. Although T is supposed to be the distance into the first. So M profile first timestamp. That's how long since we started the thing, right? So we want to divide the available space into chunks, I think. So we'll say that a float or bars or whatever. But we want to divide the available space up into bars. Columns. Column width is the amount of space that we have, which is frame interact width divided by the amount of time that we have. So that's the M profile length in MS. Does this make sense? So if we have 1 second recorded, that's 1,000 milliseconds. And if we're at 200 pixels for 1 second, and we can't show every millisecond, we get 0.2 pixels per millisecond. That makes sense. Okay. So then the distance is x. This float t times the column width, and the let's see. Then let's just draw something there, I guess. So, or maybe we'll. How should this work? They need to become buckets, I guess. I don't know. We'll just do something here. So right now we can just show a color. And then we don't have to get fancy and show like a graph with different heights. We can just fill in the bar. Like here was something captured, here was something not. I think that's okay for starters. So painter, draw a line. And then that would be from, this should really be an int then. I don't know, something like this, or maybe even round. We can just cast it int, actually, whatever. x0, and from x to, or actually, x to frame thickness. X and height minus frame thickness times 2. Color black, let's say. And then, oh shit, should we maybe use a rectangle here actually because of the column width? So I int column width plus I x plus I. We'll just try this, see how it feels. Okay, well, this did not do anything. So it's very noisy with this stuff. So what the heck am I computing then? Let's see. X becomes... I'm just making some dumb mistake here. Well, these X values look very sane. Is it that the column width is 0? So int CW is max. Column width. Maybe we were just casting it down to 0. Yeah, okay, it was that simple. So now we can see here, these are our, where we have the action. And we can actually do something kind of interesting because we can also show if we are in the kernel or if we're in the user space, because and then we can use the same color we have down here, right? So for blue, could be, this is the user space, and red could be in the kernel. So let's do that. So I guess we'll say bool, how do we, I have some hack for detecting if we're in the kernel. It's, yeah, if we're less than 1 meg, if the address is less than 1 megabyte, then we're in the kernel. That's going to change in the future, but we can do it like that for now. So sample get address to number u32 is less than 8 meg. And then we'll say color in kernel. Let's make sure that we pick the right color. So 16 inspector object red. Come here, you. What color are you? Oh shit. Okay. Which one is the right one? This one. Okay. From RGB. And what's the blue one? It's this. Okay. Important stuff. Well, that's very red. Why are they all red? I wonder if we're fucking up this thing. JQ, no. Okay, so I'm on a brush. Address. So the first one, we always ignore the first one. Maybe we should do the same here. Or sample. Wait a minute, a sample doesn't have an address. Sample has frames. Right, we have to look into the frames. As array dot at 1. Okay. We get the no, that still didn't work. Okay, I'm not doing this right. We are here, so we ask for frames, which is an array, and oh, it has objects inside it. Shit, right? So as object get address, of course, to number. All right. It's a very long chain of calls there, but I think that should work. Okay, here we go. Now, this is pretty cool. It gives you a sort of a visual representation of whether we are catching the process in the kernel or in user space. So wherever there's blue is in user space, when there's red, we're in the kernel. Just like you can see down here. Now, of course, something that would be really cool is if we could just drag out a selection here, and then the tree down here would update to only include those samples. And that's not going to be easy, but it's also not going to be hard. So, and this can be optimized to go way faster, by the way. Maybe actually it will just go super much faster if I just stop doing the debug logging. So let me just test that, because it did feel kind of sluggish. Okay, yeah, it's already way, way better, but it's very inefficient. Maybe we can profile the profile viewer later. God damn, this is so cool though. I love programming. Is that obvious? Okay, so now we want to be able to drag out a selection. Let's make it possible. Although we can commit this probably. So we'll just commit this stuff that we have so far. Git add DevTools profile viewer commit. Profile viewer. Add a timeline widget that shows samples to get with a visual timeline widget for a visual view of the sample of the profile. Yeah. User space stack frames are in blue. Kernel stack frames in red. Okay. Then let's do that. This is why we added the mouse events, right? In the right order here and everything. So let's do this. So what we want to do is we just want to have a state that you are currently dragging out a range. So we'll have a origin x value, I guess, m select start x 0, something like that, and select end x. I'm selecting false. So yeah, let's do it this way. So when you click down, if event button is not Gmouse button left, then I don't give one hoot. Same in mouse up. Okay, and in mouse move, if not selecting, again, not a hoot. So, I'm selecting is true. I'm selecting is false. And in mouse move, we'll say, oh, actually here we'll say M selecting X is event X minus frame thickness. And select start X. Actually, this should not be X, Y, or X relative to the widget. It should be sample index. Or like the timestamp that this represents. So we'll say select start time and time. U64. All right, and then we gotta compute these guys. So I guess we can do column width. Actually, what happens? I'm kind of curious. What happens if we make the thing way bigger? Do they eventually become 2 pixels wide? I mean, I was recording for quite some time there. How cool is it that you can see each individual sample? Could even do something when you hover, like it could show the individual stack of that sample, stuff like that. Anyway, getting carried away here, which is okay. So it's going to be the same as mSelect. No, not start end. What am I doing? End time. It's going to be the same as start time. And we want a way to compute this. So column width is this. Maybe we'll make a little helper. So we'll have a timestamp at X, int X. Yeah, const, obviously. Okay, and then it's my least favorite kind of math, coordinate math. Ooh. But this is no time to complain. Stop complaining, Andreas. It's not going to solve anything. So you want to figure out, based on the start, we are X columns into it. Wait, is that it? X times the column width. What does that mean? That's how many milliseconds into the profile we are. So ms into profile is float X divided by column width, and then we'll return m profile first timestamp plus U64 ms into profile. Okay, maybe we can say select start time is timestamp at X, event X. And let's say update. And we'll repaint it. And then if mSelect and time is, let's not worry about that right now. Thinking we could swap them or whatever, but it's not the most important thing at the moment. Wait, what am I doing? Update. Well, we don't need to update actually. We can just stop selecting. So that will update, and then we should paint this at the last thing that we do. So we'll do a. We can do like a little overlay, semi-transparent rectangle or something. So we'll need to convert the start time to an x value. That would be select start x is m select start time times column width. Then we do painter, fill, rect. And the rect is going to go from select start x to and y0, or y frame thickness, sorry. And then the width is going to be the select index minus select start x. And the height is going to be the frame, the height minus the frame thickness times 2. And then we just need a color from, we'll do an RGBA. I'll just type a color out. Do something grayish maybe, so black with a alpha value of 50. We'll see how that looks. So high chance that I didn't think of that correctly. Yeah, I didn't think of this right at all. So how did I mess this up? Let's see. Mouse move. So let's log what we have here. Select from mSelect start time to mSelect end time. Okay, that actually sounds kind of reasonable. It looks correctish. And then we're just painting it wrong then. So, oh shit, we need to subtract the profile start time. Okay. Look at that. We are selecting. We can actually have a little more alpha maybe, a little bit grayer. It's okay. We'll give it a hint of blue, or maybe it's okay the way it is. But just so we can see it, we'll put 60. We can think about the color later. So now we want to filter based on this, right? So what we're going to do is we're going to set the profile filter range whenever we're changing this. So we're going to do mProfile set timestamp range. We'll set it to mSelect start time, mSelect end time. And we'll do the same here. I think we'll need some way to get out of this. So maybe it should just be that you click once and you don't change the range or something like that. So if you mouse up, we'll say if you mouse up and if select start time is mSelect end time, then we will set the timestamp range to, we'll clear it. Something like that. So, void set timestamp range. Clear timestamp range. Shoot. So here, I think this one, or no, well, this is okay. Maybe we'll do, clear shouldn't be like that, it should be like this. Set timestamp range 0, 0. Okay, so set timestamp range. How is this going to work? Profile. Set timestamp range. We have to rebuild the whole freaking tree whenever this happens. So all of this stuff here, we're going to have to recompute. But that's okay. We just got to do it. So I think basically we're going to do this a bit differently. So maybe we'll just make a function that returns all of this stuff. How would that work? BuildTree, BuildTree, we can call it that. And this will be private, BuildTree, and I think maybe we'll do it this way. And samples, these are just going to be mJSON instead. And I think maybe that's okay. So we build tree. And then here, instead of creating roots, or we'll create roots like this actually, but we'll do mRoots is move roots. Model update. Okay, and what am I forgetting? You have to make sure that we collect this data right here. I guess we can do that when we rebuild a tree, but we can also do it here. So mJSON. Oh, like that. Okay, now we rebuild the tree, and then when we build a tree, we gotta look at the filter range if there is one, or the timestamp range. We should call it the filter range actually. Otherwise, it's hard to know what it is. I keep calling it filter range, you know. That should be a clue that that's the right name. Okay, so what do we do here? So whenever we are walking the samples here, we got to look at this guy to see if it's in range. So if what's it called? Timestamp filter range start and timestamp filter range end. I guess we can call it as timestamp filter range. If sample as object get timestamp to number U64. Wait, did we have 2 U64? No. Okay. Timestamp is less than timestamp filter range start, or timestamp is more than filter range end. Then we're not going to collect that timestamp. It's that simple. Okay, and then return maybe we'll do this actually as timestamp filter range. And we don't have to have 0 be the magic values. Okay, then void profile set clear if m has then return if this and m timestamp filter range, I don't know. If the start is start and m timestamp filter range end is end, then ignore. Otherwise, set all those things. And rebuild the tree, which will cause an update, and everything should come up beautifully. What are we forgetting? Oh, change the API names. Ah. Okay, come here, you big silly. Let's take a look at you. No, it didn't work. Crap. Alright, rebuild tree, not working. What did we forget? This is not rebuild tree. Here you are. So we had a profile model pointer. It's sad. Oh, we don't even have a model yet. I guess we can make the model before we call rebuild tree the first time. Simplifies things a little bit. Okay, so now if we select here, dude, look at it down there. You can see how many samples we're catching. Of course, it would be sweet if it would stay open, but that's going to be hard to achieve with if the data is completely changing. It's going to be a bit difficult to fix that with the tree view. To have everything stay open. It's possible, but it's not trivial. Okay, so you just click and let go, and then it causes a reset. That makes sense. Click. So now you can select the part that you're interested in. Now you see only that part. So this part at the end here where we're spraying, mostly, I guess. I don't even see us running the spray tool. Some of this was the spray tool. Can we not see the spray tool in the thing? Spray tool! Look at that. Spray tool, very efficient, apparently. Didn't get caught very much. It's so nice to have a profiler, and this is so cool. Of course. Okay, so let's make it so that you can select back and forth, and it doesn't matter. Let's do that in the profile timeline widget. Mouse. So here we can do something like, whenever you're moving, if mSelect end time is less than mSelect start time, then swap. Wait. I feel like I didn't think this through. Right, yeah, because then it says if we started from there, that's not gonna work. So we want to just swap them when we call to, we can swap them in here. So this will be the min of start and end, this will be the max of start and end. Okay. Oh, but we don't know how to draw that correctly. Oh, that's irritating. Damn it. Alright. I guess we should deal with it here then. Jesus. Or we can deal with it here as well. Oh, I lost it. That's fine. Profile timeline widget. Where did we paint? And start time is min mSelect start time mSelect end time. Normalized. Let's call it that. Max, and then we use this guy and that guy, and come on. Oh wait, why am I using ints for these? These are U64s. Come on, Andreas. Come on. Alright, there we go. Now we can select in any direction we like. Perfect. So, that's fucking cool. Blah, 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 blah. Nothing radical, just making it possible to filter the time. Profile viewer. Allow filtering. Filtering out. Filtering samples in a specific time range. Now select the range sample range, the time range you want on the profile timeline. This allows you to tree view will update automatically as you alter the range. Fortunately, this causes the tree view to collapse all of its nodes. It would be nice to solve this in the future so that nodes can stay open. But That's a tricky one because we are. The thing is that there's no persistence the way that we're doing things right now, right? Because we delete the whole tree and build a new tree. There's definitely some way to achieve it, obviously, but I'm not sure if the path to solving that is persisting nodes and like keeping the tree intact and like updating maybe you would go through the tree and filter in a different way. Like instead of generating a new tree, we would sort of go through the tree and filter at each node. We would filter all of its samples and see like how many samples disappear from here. And if all of them disappear, then we remove that node. And then like if we do it that way, like incrementally update the sample tree, then we could keep it intact in the view. I'm just it would need some work to do that, but it would be really visually pleasant if you could filter the profile and the tree would stay in place. But that's some serious like level of polish that I'm not gonna do right at this very moment. So I guess let's profile something fun before we conclude today's video. Maybe we'll profile the profile viewer. That might be interesting. So let's do this and let's profile ourselves, selecting a range of time, since that's what we just worked on. So let's say capture profile of this process right here, so 16. All right. Wow, it's pretty long. Okay. PV prof. All right, let me see it. Look at this. See, now we are selecting profiles in a profile of selecting profiles. Now, we don't do that every day. It's pretty cool. So it gets pretty sluggish when you select a lot of them. Okay, but anyway, what the heck are we doing in this tree? One thing, by the way, that's interesting when you do this is that here is this irrelevant noise that samples that we don't care about, because this is just me clicking on the window to activate it, probably. Or maybe getting like the initial paint from making the window active. And then actually here we get the first mouse down event. So maybe it's not super relevant, maybe a little bit irrelevant. Anyways, we can filter that out and say we don't care about that. We can also skip the very last stuff here, because that's just me messing with the profiler probably. So let's look at this range here. All of the time is spent in, or not all of it, but a lot of it in mouse move event, BuildTree, and paint event, obviously. And most of the time in the paint event is spent in JSON object get and JSON value clear. So super inefficient business going on here, because we fetch those things out with those JSON APIs, which I mentioned is going to be inefficient. This thing right here, we should pre-compute an array for this. So let's do that right away. That'll be a good little thing to do before we finish up. So in a profile, let's have a way. What was the data that we wanted for each sample? We want the timestamp and the address of the, not the 0th, but the second frame. So that's the stuff that we want. So let's pre-calculate that in the profile. And we can probably make painting use way less CPU. This part here is still going to be chunky. Although you can imagine us doing this better if we store this data differently, for sure. Because here you see that in the rebuild tree we are doing JSON object get, and the JSON object model that we have, it's not efficient, like it's not smart. So when you get like an object within another object, then it makes a copy every time. There's no way to avoid the copy. So you see that here. It's quite significant amount of samples, or it's like slightly more than 10% of the total. We should do a percentage, by the way. That would be a really good thing to have. But you can't do everything at the same time, so let's just fix up the paint event performance here. So, profile. We can call it sample data or something like that. Sample data. And we can expose that const vector sample data. Struct sample data. And this will just be U64 timestamp and first address, or we'll call it address. That's where we caught you, basically. So when we first create a profile, we'll go through the samples. So for each sample, m sample data, ensure capacity, and JSON size. Just pre-allocate the right amount of space for it. For each sample, and what is one of these samples? Oh, I guess we can just do it this way. For each sample.get this object. Well, we have everything in the timeline widget, so we want this and this. Timestamp, and actually we only want to know if it's a kernel one or not, so we could store that slightly differently. Sample data. Append. Okay, so we'll store that. Sample data and in kernel. What am I doing? False. Okay, blah blah blah, and this should allow us to walk over that thing instead. So sample in m profile sample data. In kernel. And oh, I guess we just do that now. So first thing, let's see that it works. Loopy doop. Yep. Okay. So let's profile ourselves a little bit. P profile 16 on. Select the little range here. La 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 la. this is pvprof. We close this down and open this up. All right, what can we find? Look at that. Paint event has been demoted to a secondary issue. And in fact, it's tree view paint event profile timeline widget is not heavy at all anymore. That's quite nice. So very good. Now the majority of time is spent in mouse move event where you rebuild a tree. It gets very sluggish over here, so building the tree is quite costly and something that we can definitely do better. But we don't have to solve everything right now. Still, it's super, super amazing to be able to have a profiler so that we can actually optimize the things that matter. Too cool. All these strings that we're creating. Oof. Why are we doing that, I wonder? I guess we are probably rebuild tree. Is it that we're passing a string to this every time? Oh no, we are. Oh, all of these create strings. Because get takes a string, so we have to make a string every time we call get. And that's all of these. Well, we can stop doing that right away, I think. Members find. I wonder if we could just simply use a string view here. Would that just work? I feel like it's not going to work, but we'll try it anyway. Maybe that did work. If so, that's super awesome. So calls find with key. What happens then? Key traits hash. I feel like it's going to become promoted to a string anyway. Equals. It's going to convert it to a string. We have to do better, but we're so deep into this now anyway, so I'm going to have to call it a day at some point. PS profile 61. I just want to verify that that was true. Oh, wait, where's our string? It's here instead, in get. Oh yeah, here it is. Right, so we're still creating the strings. They just end up in get instead. So that's something else that we can do better. So, room for improvement, but still some kick-ass stuff. So, JSON object. Let's not make that change. But we'll do this change instead. So, profile here. Pre-compute timestamp and in kernel state or per sample. Instead of fetching these from JSON in every paint event, make a separate sample data vector that can be iterated. This optimization was made possible by profiling. Profile viewer, and then analyzing about profile with profile viewer. Cool. All right, so this is going to be it for today's video. And I want to thank you for watching and for hanging out. And I hope you saw something interesting here today, because I certainly had a lot of fun. And yeah, what is the thing that if you would like to support my work, even though it will always be free and open source and all that, you can check me out on GitHub sponsors and Patreon. There are links in the description. But if you're not interested in that, it's fine. We can just hang out and do programming anyway. It doesn't matter. But I am very grateful to all the people who do support me, so thank you. And other than that, I'm just going to go have a weekend, so see you all next time. Bye.